Hello everyone. We prepare for solar potential in Turkey. We prepared with Osman Kaçar and I am Gökberk Batuhan Zorlu. Introduction. This report discusses the solar potential in Turkey based on the findings of a study that utilized artificial neural networks to predict solar radiation. The study considered meteorological and geographical data from 12 cities in Turkey to develop an equation for estimating solar potential. The report highlights the solar irradiation levels, the application of ENS, and the results of the study. We can see that Turkey maps of the temperature in the side by side of Turkey's points. The red point is the highly decrease point, and gets the blue color. That point is the decreased level of the temperature. Turkey has significant solar potential due to its geographical location and climate condition. The country receives an average of 604 hours of sunlight per year, making it an ideal location for solar energy generation. We can see that graphic growth by the years. It started in 2008 to get until 2015. We can see the percentages of the MW. Solar potential in Turkey, if we talk about. Turkey benefits from abundant solar resources due to its geographical location between latitudes 36 degrees and 42 degrees north. The country experienced an average of 2.6 kilowatt hours / meter square of solar radiation per day, with a total yearly radiation period of approximately 610 hours. The Mediterranean climate and ample sunlight contribute to high solar potential in Turkey, like we see in that table. Artificial neural networks, shortly NES. Artificial neural networks are computational models inspired by the human brain's neural structure, and are capable of solving complex problems and have been applied successfully in various fields. In this study, ants were employed to model the solar potential of Turkey based on meteorological and geographical data. We can see the input, hidden, and output. This look like brain, like they said. Application of N for solar potential. The study used ants to estimate solar radiation intensity in Turkey. The input to the network includes latitude, longitude, altitude, month, mean sunshine duration, and mean temperature. The output was the solar radiation intensity. The backpropagation learning algorithm was employed with a feed-forward single hidden layer architecture. In this table, we can see weather forecast day X, which includes day R, environmental temperature, wind speeds, humidity, pressure, cloud cover. That impressed the neural network WIX BAS1, that clear sky physical model. And in the right side table, error day X, the green one hard average predict power, and the blue one is hard average measure power. Like we see, that start point 0 and gets until the high level, and after that the point that decrease until the 24. That actually see us the hours of the day, 0 to 24 hours. That's one day. sun likes, we can see that. Solar irradiation. Turkey has one of the highest solar irradiation levels in Europe, with an average of 1,500 to 200, 500 kilowatts hour meter square per year. The southern and southeastern regions, such as Mediterranean and southeastern Anatolia, receive the highest solar radiation. Geographic advantage. Turkey's geographic location provides a favorable position for solar energy generation. The country is located between 36 degrees and 42 degrees latitude, which places it in a prime position to receive ample sunlight throughout the year. Solar farms and rooftop solar. Turkey has several solar farms with some notable examples like the Konya solar power plant with a capacity of 20 megawatts and the Karapınar solar energy plant, which aims to become one of the largest solar power plants globally with an expected capacity of 1,000 megawatts. Besides utility-scale solar installation, Turkey has also seen an increase in rooftop solar system. Homeowners, business, and industry facilities have been adopting solar panels to generate electricity for their own consumption and sell excess energy back to grids.
Results and discussion. The performance of the neural network model was evaluated for the selected cities in Turkey. The statistical values, including root mean square, error, coefficient of determination, and mean absolute percentage error, were analyzed. The results showed that the M model provided accurate predictions of solar radiation. The MAPI ranged from percent of 1.3 to percent of 1.8, with the highest accuracy achieved for the city of Artvin. Renewable energy targets. Turkey has set ambitious renewable energy targets to diversify its energy mix and reduce dependence on fossil fuels. The government aims to achieve a percent of 30 share of renewable energy in electricity generation by 2023, and the National Renewable Energy Action Plan sets a target of 10 gigawatt of solar energy capacity by 2023. We can see that the research shows how renewable energy shapes up in this table. Solar energy actions to attract investment and encourage the development of solar projects. Turkey has implemented a competitive action system. These actions determine the tariffs for electricity produced from solar power plants. Successful bidders are guaranteed license to develop and operate solar projects. Research and development. Turkey has also focused on research and development in the solar energy sector. Universities, research institutes, and private companies are actively involved in developing advanced solar technologies, including concentrated solar power and solar photovoltaic systems. Integration challenge. While solar energy presence great potential, there are integration challenges that need to be addressed. As more, solar power plants and distributed solar systems come online, the grid infrastructure needs to be modernized and upgraded to accommodate increased renewable energy generation. Energy storage technologies and smart grid solutions are being explored to enhance grid flexibility and stability. Regional differences. Solar potential in Turkey varies across different regions. The southern and southeastern parts of the country, characterized by a, by a, by a Mediterranean climate, receive higher solar irradiation and have more favorable conditions for solar energy generation. However, solar projects can be implemented in various regions throughout the country, taking advantage of available land and rooftop space. Conclusion. The study confirmed the effectiveness of the N-based estimation technique for predicting solar radiation in Turkey. The results demonstrate that the N model outperformed classical regression models used in previous research. The findings highlight the potential of N's for evaluating solar research potential in regions without established monitoring stations. The accurate estimation of solar potential is essential for various applications of solar energy in engineering, architecture, and meteorology. In conclusion, Turkey possesses significant solar potential due to its favorable geora- geographic, geographical location and abundant sunlight. The application of artificial neural networks provides a reliable method for estimating solar radiation, enabling better utilizing of solar energy research in the country. Thank you for your attention. That's the end of our presentation.